Hey everyone, on the previous lessons we studied routing, and on this lesson we're going to see how we can check the routing table and the environment in the terminal of our operating system. So first of all, we open the console, we open the terminal of our operating system, we have a Linux type system, and here if we want to check the routing table of our house or of our office, the environment where we are working, we can just type here root -n. If we type this command in Linux, this is going to show the routing table. So we press the enter key and here we can see. So we have two entries. The first entry is the default route when we want to go to the internet, and then the second, the network that we are connected to. So we can see that our network is this one, 872.27.224.0. Right? The gateway is 000 because we have a direct connection, as we learned on the previous lessons. Remember, when the gateway is 0, it means that we are directly connected to this network. Now, the mask here is a mask of 20 bits for the net ID. Keep in mind, here we have 8 bits in binary because it is the 255. Here we also have 8 bits, and here we only have 4 bits, so 16 plus 4, 20 bits in total. Right? So we can draw this, where here we can see that this is the network that we have, right? And here, this cloud that we see on the right is the internet, okay? This is the default code. Whenever we want to go to the internet, we need to use the default route. Now remember, whenever we need to go to the internet, we need to pass by the router. Now here, in the routing table, we see that if we want to go to the internet, we need to pass through this gateway. So this gateway that we see here, point 1, is this gateway of the router, of the interface of the router, okay? This is the point 1. So it is where we need to pass through when we need to send a message and go to the internet. So whenever we want to send a datagram from this PC to the internet, we need to follow this path, right? The gateway is where we reach. So we reach the router in here. So this is the gateway, very important, not this one. This in here, where we reach, okay, the path where we arrive to the router. In this case, it is point 1. Okay, so let's come back to the routing table. The first thing that we know is that we have two networks. We have the directly connected network, right, and the default network. Also note that the order where the addresses are represented is first we see the default network, and then we have here the directly connected network. So if a datagram arrives and we look at the order of the destinations where the routing table is represented, we'll send it always by the default network, because the default network comes before, okay, the directly connected network. And this is not correct, because if I want to arrive to my network, I have to send it directly to the destination, right? This destination. I don't, and I mustn't send it through the gateway, which is the gateway that I use to send to networks that are far beyond to my directly connected network. We can already see that the order that are represented the destinations where we use the root -n, so to show it, and the order that they are displayed, this destination is not the order of consulting when a datagram arrives or when it needs to be sent. So the consulting order is different. So essentially, what do we do in a directly IP level when we consult the table? Well, pay close attention. First of all, okay, it checks if the datagram destination is one of the addresses of my interfaces. So here in the console, for instance, if we want to know the address of our interface, we can just type ifconfig. If we just type ifconfig, here we can see the interface, and also if we just type ifconfig, and then we'll specify that we only want this Ethernet interface, so here we just type ETH0, okay, like this. Here we can see our IP address, okay, here this is showing the IP address, which is 172.27.228.854. So once we know our IP address, following this first check, the first step, right, in this algorithm, well, we need to check if the destination is one of my interfaces. So here, if we do a ping, Remember, with the command ping, we transfer data packet to a specified address along with a ping message. It is a very useful way to check the connectivity between addresses and also to get the reply from the host or the server. So we can carry out this experiment. For instance, if we do a ping to one of my addresses or one of my interface, in this case, my IP address. So here we just type 172.22 and here we have 27.228 and 154. So if we just type a ping here, we press the enter key, we can see that we have response, right? We have response because we are able to connect to this destination, which is our IP address. In fact, when we do this ping and we perform this ping, the response that we are getting is a response from our own PC, right? From our same PC. So essentially, when we do a ping to another interface, right, and we do an IP interface, not our own, of course, the datagram is not going to be responded by your own PC. It goes directly to the loopback interface, which is what we have at the beginning here, what we see as sending the datagram to upper layers. This is the same as sending the datagram to the loopback interface, okay, the loopback interface. So first of all, we check if the interface is ourselves, because if it is ourselves, then we are not going to send this datagram to another physical network, because no one is going to respond, because ourselves is the destination. So in that case, we send it to the loopback interface. In fact, here we can see in a Unix machine, if you just type ifconfig, okay, here we can see this is the loopback interface. This hello is the loopback. Here we can also see, okay, the loopback interface. Okay, very well. So now we can carry out a very simple experiment. We can use the TCP dump to record and capture what is sent and received through the loopback interface. So what we are going to do is we're going to open a new terminal to perform this experiment. Here we have now two terminals, right? So on the first one, the original one, we use TCP dump, sudo TCP dump. So with the sudo, we have here super user permission. So TCP dump. Now we use the interface of the loopback. So we press the enter key. Okay, now we are listening on the loopback interface. So we are going to capture, we are going to record any datagram that is sent or received through this loopback interface. And now on the other console, we are going to send the ping to this interface. Remember that this interface, okay, of our own is this one, right? It is a ping to this interface here, which is our IP address. Okay, so we press the enter key. Okay, we press the enter key, and as we press the enter key, we can see that we are capturing on the TCP dump, okay, these messages that are being sent inside the loopback interface. This is because the datagram of the destination of the ping that we are sending is an address of our interface. So in that case, we are sending the datagram here to the loopback interface, right? And we have just proved this. Now, if the IP address, if the destination is not mine, then we go to the step 2, and in that case, we need to consult the routing table. And now remember that this checking is done performing the longest match principle, okay, also known as the longest prefix match. So what we do is we check each entry of the routing table ordered from the longest mask to the shortest mask. So in that sense, the first entry that we check is the one that has the biggest mask, right? The longest mask. So it is not complex to see that the default network, the network to go to the internet, is the last one that is going to be checked. So in fact, here in the routing table, here in the console, if we just type root -n, we can see our routing table. So we have only 2 entries, and this mask is basically all of them to be 0. Okay, and this mask we have here 20 bits, because we have here 8 bits plus 8 bits plus 4 bits, the first 4, okay? So we get in total 20 bits. Of course, this mask is the largest one, okay? And this is the smallest. And always is going to be the case that the default network, okay, the network to go to the internet, is the one that has the smallest mask. This is because this is always the last one, the last entry that is going to be checked. If we have, imagine that we had more entries in here, the default network, okay, is always going to be the last one to be checked. Why? Well, because the default network always has a possibility to go, always has a path. So if we check this one to be the first, we will always go to that path, right? So we only arrive to the default network if, after consulting all of the other entries in the routing table, we found no compatibility without the network, so none of them, okay, match our destination. In that case, we go to the default net because that's going to provide a possible case. This is the reason why the gateway here is all of the match to be zeros, right? And we can see here that to go to this default network, very important, the mask is all zeros, right? So very important, the longest match principle. And so now the last step is to forward the datagram. Then what we see here is if it is a direct routing. What it means that this is a direct routing? Well, when it says it is a direct routing, this means that the router gateway is 0000. Essentially that we are directly connected to this network. This is what is called as a direct routing. In that case, we send the datagram to the datagram destination IP address. Okay, otherwise, if this is an indirect routing, so in indirect routing, the gateway is not 0000. Okay, in that case, what we do is, of course, we need to send the datagram to the gateway IP address. So then when we arrive to that router, this router, given the routing table of that router, is going to retransmit the datagram to the destination or to another router. Depends how many routers we need to pass and cross by. Very well, with this we end this first lesson on the routing and environment using the terminal.